24 light-years away, in the depths of the stellar ocean, hides a world surprisingly similar to our own. It cannot be seen with the naked eye. It conceals itself behind the light of a distant star that quietly twinkles in the night. Officially, this planet is called K218b. We have named it Pantea, a name we invented to bring this mysterious world closer, making it more relatable and alive. Planet Pantea was discovered through careful study of the distant star's flickering light by the K2 Space Telescope in 2015. These barely noticeable variations, like a message from the depths of space, allowed scientists to realize that a real world was orbiting the star, hidden in its shadow. Pantea orbits a star called K218, located in the constellation Leo. This star is a red dwarf, significantly smaller and cooler than our Sun. Despite its lower brightness, K218 emits stable light and heat, creating unique conditions on the planet's orbit. Its location in the constellation Leo helps determine the exact position of the system in the celestial sphere and study its properties. Pantea is a rocky planet with a dense structure and a solid surface. Its diameter is about 2.4 times that of Earth, and its mass is about 8 times Earth's. Such mass generates strong gravity, far greater than Earth's, affecting everything on the planet, from the atmosphere to geology. A year on Pantea lasts about 33 Earth days, and its orbit is quite stable, creating relatively constant conditions. Despite its powerful gravity, the planet can retain a dense atmosphere in which water vapor has been detected. Pantea's atmosphere contains a significant amount of water vapor, one of the most important discoveries made using spectroscopy. The presence of water vapor suggests that liquid water could exist under suitable pressure. Water in the atmosphere may form clouds and influence climate processes, enabling a complex meteorology. This combination of factors makes Pantea a unique world, where the water cycle could be active and the atmosphere dynamic and rich in various chemical compounds. Temperatures on Pantea range from about -30 degrees Celsius to +20 degrees Celsius. These conditions allow water to remain in the atmosphere as vapor and potentially in liquid form on the surface. Thanks to these temperature ranges, Pantea lies in the habitable zone of its star, an area where climate conditions could support complex atmospheric processes and an active water cycle. Its surface is covered with oceans, seas, and rivers, forming an extensive hydrological network that shapes the climate and creates unique landscapes. All of this makes Pantea particularly attractive for further research. About 90% of Pantea's surface is covered by oceans. Only small rocky islands and outcroppings rise above the water, forming a rare and striking landscape. If life could have evolved on Pantea, it would likely have been radically different from anything we know of Earth. On a world where 90% of the planet's surface is ocean and land is limited to rocky islands, it is logical to assume that most life would exist underwater. Pantea's deep oceans might be home to slow-moving massive creatures that could withstand high pressure and gravity. Their bodies might be dense and streamlined, adapted to the powerful ocean currents. In the dim light of a red dwarf, vision might play less of a role, and sensitivity to vibrations, heat, or electrical impulses would be the primary way of perceiving the world. In the upper layers of the ocean, near the rare patches of land, simple photosynthetic life might thrive, taking advantage of the weak but constant light of the star. Perhaps Panthea's seas are covered in oceanic forests of flexible algae, swaying in an endless underwater dance. Given the dense atmosphere and active water cycle, gliding aerial life forms. While all this remains speculation for now, it allows us to imagine how diverse and unusual life might be, if it does exist on distant Pantea. Whether Pantea's weather is highly dynamic and dominated by powerful forces of nature. Thanks to its dense atmosphere, vast oceans, and rapid rotation, intense hurricanes and storms frequently rage here, sometimes lasting several days. The planet's fast rotation strengthens wind currents, creating massive atmospheric circulation systems. Combined with high water vapor content and stellar heat, this leads to large-scale, intense storms that shape harsh and unpredictable weather. Pantea also has its drawbacks. It lies in a region with a high density of meteoroids and asteroids, meaning that its surface is often bombarded by space rocks. These impacts create dangerous conditions and may affect atmospheric stability and climate processes. However, It is possible that these meteorites and asteroids deliver diverse chemical and biological elements that could play a crucial role in the development of life. Pantea is one of the few exoplanets with vast oceans and a dense atmosphere, making it unique among known super-Earths. Its size and mass are much greater than Earth's, generating strong gravity and stable surface conditions. Unlike many planets orbiting red dwarfs, Pantea has a relatively short year and fast rotation, influencing climate and weather patterns. Compared to other exoplanets, Pantea stands out for its potential diversity of landscapes and weather, making it especially intriguing for study. Studying Pantea became possible thanks to modern space telescopes and spectroscopic methods, which allow scientists to analyze atmospheric composition and detect subtle changes in the star's light. Space observatories like the K2 telescope and newer instruments continue expanding our knowledge of the planet, helping scientists study its climate, atmosphere, and potential signs of life from a great distance. These technologies are key to understanding distant worlds and the future of interstellar exploration. Future research on Pantea will focus on more detailed studies of its atmosphere, climate, and possible biosignatures. Plans include launching new space telescopes with improved sensitivity, capable of more precise atmospheric analysis, and searching for traces of organic molecules. Missions may also investigate the effects of meteorite impacts on the planet's chemical makeup and the possible origin of life. All this will help us better understand Pantea's unique world and its potential habitability. Pantea is more than just an exoplanet. It is a symbol of hope, inspiration, and humanity's thirst for discovery. In its clouds and oceans, we see the reflection of our dream to find other worlds, understand the universe, and perhaps not be alone in it. Each new observation reminds us, even at a distance of 24 light years, we can connect with the unknown. Pantea inspires scientists, engineers, and dreamers all over the world. It reminds us that space exploration is not just science, but a path to a future where anything is possible. Pantea reminds us of how vast and mysterious the cosmos is. Every such world is an opportunity to rethink who we are, where we came from, and where we might go. Perhaps one day we will send probes, or even people, there. For now, we keep dreaming and exploring. If this story about a distant planet inspired you, give it a like, subscribe, and share it with your friends. Thank you for joining us on this imaginary journey. See you in the next stories about stars, planets, and the great mystery of the universe. To new horizons.